All right, good morning. We are here on, I believe, day 12 of ClickRigs design stream. We're working on the TB RD01 ClickRigs trophy truck. It'll be the second trophy truck in the collection. And today we've got a first batch of some production pieces. So they're not all packaged up how they normally would be, and they're in the colorway we've kind of been working with in the design stream so far, kind of based on feedback and some of the renders we did, and kind of looking at two different versions, the orange and gray, and then kind of a gray and like a green blue color. And so what we'll probably, I'm sort of leaning toward the orange, but we'll manufacture some in the gray and sort of the aquamarine green blue color, and see how people like them kind of in both colors in reality outside of the renders, and pick one. But for now and today, we're going to be doing a first test assemble of the production pieces, just to make sure that we got all of the components in the kit, that we're not missing anything, or that we don't have extra parts, and make sure that all the parts work well, and that there's just nothing that we missed in all of the prototyping. And if that's good, then the next step is essentially to onboard all of the parts, get them into an official production kit, choose a colorway, and then release it on the store. So it's almost 100% certain that this kit will be available for sale for purchase in the store this week. So, and we'll be sending out an email too. So if you're not on the emailing list or the email list, go to clickrigs.com and sign up for it. And that's where we announce all the new stuff that we make, plus discounts and stuff like that, which we run frequently. So anyway, let's jump into the overhead here, and let's get to assembling. Let's see. I probably do not need my keyboard. At least not right this second. Okay, so like I said, this is the box it would come in, but normally this stuff would all be packaged up. But regardless, I kind of like to just get the parts kind of separated out. So you're going to have, in this case, this kit has 5 tires. I'll just kind of put these over here for now. 5 wheels. And you normally just put the wheels, tires, and bearings kind of in their own little initial pile. Then we should have 5 bearings in here. And these bearings, by the way, are just it's a standard 608 skateboard bearing, and so easy to find replacements for if you ever need them. They add a nice bit of heft to the kits, and if you want, you can easily find some very fast rolling bearings. All kinds of companies make them, which could be swapped out for these. These are standard, and in some cases having a little bit of friction in the bearing isn't terrible. But if you want something that rolls down a hill like crazy, it's easy to find bearings that can do that. And so we've got these little trays here. Some people use bowls. Some people just scatter them out all over the bench. I like to take all of the elastic parts kind of out first. So we're just kind of separating the parts. And then there are a few ways to do this. I usually separate out the parts that don't need snap dots. And then the parts that do. So essentially, if it's got a little pocket, and if it needs one of these snap dots added to it, then it's going to go in one pile, And then if it's something like this that doesn't have any snap dot receptacle, I just throw it in another. You can do this however you want. Everybody's got their own method. That light is pretty cool. We got our major actually this light does get snap dots. Okay, and so that is all of the pieces. I'll just set that aside for now. And this kit will also come with essentially bags of snap dots. I've just poured some out here. We may need more, but I'll start with that. And so we can just start with some of these major body pieces. Maybe. The trick with the snap dots is getting them to go in straight the first time. And so you can use your hand, you can use the tool. I found too, if they sometimes don't want to start straight, you can get them started with the tool and sort of do a little bit of a twisting motion. And we've been trying some different settings on these bodywork parts. And so it feels like the snap dot receptacles on these are a little bit tighter than usual, which isn't terrible, but you want to make sure that it's not too hard to get the snap dots in. But just to check, I'm going to go in and look and make sure that we've got the right right geometry going on in this part. Again, this is just a test assembly, so let me, I'm just kind of going to the CAD and just double checking as we go. So what we're going to do is we're just going to go through and we're going to put all the snap dots in the pieces that need them. And actually that is one thing I did not include in here. I forgot the snap studs. I probably don't have. Let me see if we've got stored in the printer. I'll just print some real quick, and by the time we need them, we'll be done. They'll be done. I do not, but that's okay. We can fix that here. Let's get our keyboard back for this. Let's jump into Slicer, I believe. So let's go to the model catalog. I just need to find the snap stud component, and let's try there we are, CR38. So we can just go back to the slicer. We're going to import. I'm trying to think how many of these do we need. Right, 1, 2, 3, 4. Let's just do 20 of them. Excellent. All right, so let's jump back into the overhead. While that's by the time we need them, those will be printed. And so this cab gets snap dots on the top, but in the bottom you could put snap dots in there, but the bottom of this cab will not get those. It'll actually get the snap studs that we're printing, and that will convert this into a male stud so that it can snap onto the top of the chassis. So we'll just put the snap dots in the top for now. We've got these little recessed snap dot receptacles, so for that it's definitely easier to use the tool. I'll try it without. Yeah, definitely harder. That's another method. Is essentially just get it kind of squared up and then do a quick push. Sometimes that's hit or miss though. And then this one will get there and there. I want to check something real quick. And again, this is going to get the snap studs, so we don't need to put anything in there. Second, but I want to check. We did some other parts with different settings. I just want to double check those too. So they're about the same. Okay, so that feels more like the normal ones. Okay, good to know. Just double checking. Okay, so we are assembling some test production components for this kit. Right now we're just installing the snap dots. My guess is this kit would take probably 45 minutes maybe to assemble. Maybe an hour if you've never done one before. So a little more. The more I think about it, the more I'm wondering if we should actually do it with, because these were some test settings and they do feel a little bit tight, so I'm almost wondering if we should just maybe use these parts instead. Not these though. Let's yeah, these feel more correct. So we're going to do the green test components that use our standard production settings. So let's see. There are a few of these parts that have the newer design, so I'm going to keep those. But this is pulling out all the parts that need snap dots. Excellent. Okay. Sometimes I just like to dump them out into a little pile. makes them easier to get to. I think this one. Was missing its chamfer one way, but let's double check, make sure that is yep. So that's the issue there. So this is why we do these test assemblies, just to make sure that we haven't missed something dumb and obvious. So this snap dot receptacle here is supposed to have a chamfer. So let's just go add that. Basically the chamfer helps guide the snap dot in. You can still get it in without, but it's a lot more difficult. So that's supposed to go to 0.4 chamfer, just like that. And while we're in here, let's check the grill. Yep, that's got them. This one doesn't though. Perfect. Okay, back to the overhead. It's a fine balance. Basically, you want these snap dots to just pop right in, kind of a little satisfying snap. If they're too tight, it's just kind of annoying to assemble, and if they're too loose, then the connections aren't tight enough. Again, we've got this recessed one here, so using a little tool. And again, the bottom of the cab does not get snap dots, it gets the snap studs, which we're printing some. And we're just going through, and it's just a test assembly, just to kind of discover all the things we may or may not have missed. And so we're just going through and punching all the snap dots into the parts that need them. And once we have all the snap dots in, we'll just click all the pieces together. See, that one's tight. So we may have missed a chamfer on that one. Let's get these top ones in. We'll get them all in, but my guess is we missed that one. I missed that one. Again, it doesn't affect how the snap dot works, but it does affect how easy it goes in. You shouldn't ideally have to fight these. Okay, so we got them in, but let's go double check that. Let's just show up these parts here. Sure enough. Okay. .4 millimeters makes all the difference in the world and how enjoyable it is to assemble. Let's just make sure we have the right part. Yep. Okay. This is a catalog part, so this one should be good, but I just want to double check. Yep. Hello, whoever you are. In case you're wondering, I'm currently assembling a set of test parts for one of the new ClickRigs trophy truck kits that we've got in the store. I don't know where you're from or who you are, but I see there's one person viewing. So hello. Admittedly, you jumped in probably to one of the less thrilling parts. I'm just inserting all these snap dots. Hello. We're just assembling a test kit. I'm doing the boring part, just putting in all the snap dots and just kind of double checking if anything looks strange. We go in and fix it in the CAD. So like these I almost feel, let's go check. So let's go to the browser. Yep. Okay. Just putting the snap dots in all of our test pieces. And we're going to assemble it. I'm just kind of going through, we're looking for any quality issues, any critical features we might have missed, any components that we didn't get in the kit. On the home stretch here. I'm curious if we missed those two. Which one was that? Haha, sure enough, we did. Right there and there. Okay, let's switch to that. We're going to fix that. Voila. Excellent. This is why we do a test assembly. Which means these are going to be a little harder to get in. And downright impossible, maybe. It's amazing how much difference 0.4 millimeters makes and how easy these snap dots. So when you miss one, which we just fixed, but we missed two of them on this part, which is why we're doing this this check. This would not be this hard to get in. I think we found like 10 of those so far. This kit should be up in the store at some point this week. Last one. Alright, so we've got all of those pieces. Now let's figure out a build order here. So we're going to start with this. I'm just going to refer to the Okay, let's start on the front. So it's essentially going to be that. And then let's see, let's throw the bearings on. There you go, just until that kind of pops through. That's why it's easier to get these bearings on. Could add a little more chamfer to that. Just until that pops through. But it's easier to add these when it's flat. Let's take our two short ball end links. Oh. However, helps if you don't put this on upside down. That's more like it. And then we'll take the lower A-arm stiffeners, kind of snap those into place. I'm just building the front unequal length A-arm suspension. I'm just going to kind of wrap around like that. And these little ball links come in different lengths, so you can tune the ride height by swapping these out for a different length link. You can also swap the butterfly spring out, so you can change ride height and you can change spring rate independently to kind of tune these. And let's see, I want these. Sweet. So now we got fully functional center pivot, unequal length A-arm setup with tunable ride height and tunable spring rate. So that's pretty much our front end. So now let's move on to the back end. Let's see, let's add the top hats to the axle. It's kind of a hex and a hex, so this just kind of snaps on just like so. What that does is that gives this rigid axle a little bit of elasticity to retain the bearings. And we'll just go ahead and throw the bearings on now too. Takes a fair bit of force to start it. The upside is that they probably will not come off. You just want to get that little lip to poke through, just like that. And now that whole bearing is solid. Again, this is just a test assembly, so we're kind of working out what the best methods are. I kind of wonder too, so that was putting the top hat on first and then the bearing. I kind of wonder if we do it the opposite. It's easier to get on that way. The question is, can we get it on? Actually, I think that's the best method, so we'll keep with that one. Top hat into the bearing, bearing top hat assembly onto the axle. And so we've got the front A-arm suspension all assembled. Now we're working on the rear. So let's go ahead and just snap the stiffeners into our trailing arms. And into our upper triangulated link. And so let's see, so the trailing arms are going to connect there. And there. Just like so. And then these side pods are going to snap over that. But we need to pick up the struts that will support the rear tail of the truck. So let's assemble these struts. And the struts are going to go right here. Right here. And so now we can put the side pods on because those are going to kind of retain those. Actually, I forgot, yeah, that one doesn't get retained. So we could have put the side pod on first. And so we're just building out the rear suspension. And then we're going to get the triangle link, which is going to go right there. But let's put the hole down. So that little piece kind of holds the struts down, and then it's going to tie into that piece. And that piece picks up this triangle link. And this triangulated link will connect to the axle, and that's what essentially locates it in space side to side. There's that, and so we should be able to, let's do the lowers. So this is our little axle truss, and this will clip onto the axle. Just like so. And again, all these parts are interchangeable, so we have a bunch of different rigs, and you can swap them out to build different new rigs. It's kind of like Lego, but for off-road trucks. So now we'll put in the triangle link. Let's just get these out of the way, because those are kind of go above that. That will snap on. And so now you can kind of see we've got a, let's ignore these for now, a fully triangulated rear axle that can move up and down, just like on a trophy truck. And then while we're at it, these have these little retaining clips that just kind of clip into these divots. So let's get those on. It just helps retain the axle, so because these things are meant for dynamic play. They're essentially like off-road soapbox derby cars. You can build ramps and create obstacles and jumps and send them down the ramp and kind of tune them. You can also push them over terrain. We are working on a terrain system. And so these clips just, oh, wrong one. Clip on like that to retain that axle. And these bearings are 608 skate bearings. So we've got a triangulated 4-link live axle rear end, and then we've got a center pivot unequal length A-arm front end. So you can kind of see that's essentially replicates what you've got going on in a trophy truck. So now let's add, but we made a mistake. I made a mistake. This trailing arm is put on backwards. No biggie. Like I said, this is a brand new kit. It's not in the store yet, so we're just working out an assembly method. Probably have to take that clip off too. Let's swap that around. That's better. You know, in a big crash, these are, parts can loosen up and fly off, but you just snap it back together. So to a certain extent, they kind of also simulate sort of realistic crash damage. Let's see, do we have that right? Yep. Let's throw our clips back on. Perfect. Okay, so now let's do, so we've got these rear springs, these go in here, and then they connect to these same ball end link, and that's your link to your spring to the trailing arm. And again, these, you can get these in different lengths, and so you can tune the front and rear ride height independently, and then you can also get different thickness springs, so you can tune these springs as well. So and these springs just kind of nestle in that little nook. Just like that. Pop the ball end links in. And so now you've got just like that. And we'll just fill in some of the chassis bits. It's going to get a little 1x2 connector. Let's see, let's go ahead and grab the these little guys. We'll start putting together the cab and the tail and the so we'll install these snap dot connectors here. You don't need one in every position. I just kind of like to do the extents, and I just use a regular connector to help install these. And so essentially that snaps on just like that. And this one gets that connector. And that's going to snap on there. And then these struts come into play. So we're going to take that, and it just connects right up in there, and what it does is just a strut brace that stiffens up this tail. And there's some pretty tight packaging at the rear of this thing. You know, you've got all these, so as this, you can kind of see the axle tucks. And let's see, and then we've got this. Oh, we missed a snap dot up here. brace that just kind of helps tie those components together. And then we've got our side pods, and those are just going to snap right over like that. And then on the bottom, they get tied together with this 1x3. And then we've got our spare tire peg, which the spare is going to go here. The spare on this one goes on the bottom, but this is a double peg, so that if you wanted to, you could run a, just kind of snaps through just like that. You could run a second one on the top if you want to tune the weight and have more weight behind the rear axle. Let's see, and so one of the things that I shouldn't have done is put, these get snap studs, not snap dots. I'm going to have to pull that out. I don't know if, yeah, I'm going to have to go grab some pliers. 1 second. And we're just going to use these pliers to pull these two snap dots out. Because we actually want these. And I don't have another piece here handy, so we can just use the pliers to put these into. And this part is going to snap onto the, this is the grill, and it's going to snap onto the front of the hood. Just like that. And then let's see, what do we? Forgot I put the lens covers. So these two individual lights go onto the hood there, and then the 3 lights will go on the top of the roof. I'll just pop the grill off for a second. I can put these snap studs in. Again, it's easier if you have another, I wonder if I could use this, probably. Let's use pliers, since we have them. And again, not every, all the extra holes are really just there so that you can use these components to kind of like make up new stuff and use them in your other rig creations, but you don't need a snap stud in every one. This one I think just gets the 4. And so that snaps on just like so. Let's put the grill back on. You can see that A-arm tucks nicely up, and this thing can pretty much, it's hard to see from this angle, but this thing can pretty much bottom out to the skid plate on the chassis. So now let's finish off the light bar. Snap the lens covers on. Snap it into its mount. Maybe. Just like that. And this one too gets a couple of the snap studs. And that's going to go right on top like that. And so now, let's put the wheels and tires. This is the spare, so it gets just the bearing added to it directly. And the tires just kind of pop over. Then we'll add the wheel covers. Glorified name for hubcaps, but and then we'll snap all these wheels onto the bearings. The easiest way to do that is to kind of hook both your fingers, because you can't just push against the suspension or it moves, so you just kind of want to get it. You just pop in just like that. And then we'll throw the spare on, and the spare just kind of and the only thing we don't have in this are the limit straps. Oh, you know what I did though? I reversed the ball end links, so you can kind of see this is super stink bug, like way too much. I put the long links in the back when they really need to go on the front, and I put the short ones in the front when they needed to go in the back. So let's swap that out. So the rear ones are pretty easy to access. You can just kind of pop them off from the side. The front ones are a little bit trickier, but so the best way is to, I found, at least with this new front end setup, pop the hood off, and then I actually just pop these little connectors, and that just exposes the whole front end, and you can kind of just get in there and take these off. Let's just swap these out now while we have it apart. These just snap in. It's just a ball and socket joint. They also provide a little bit of friction in the whole system, which acts as a damper, since these don't actually have like hydraulic shocks. And just like real springs, these springs do take a little bit of a set once they've had some load on them for a while. We do recommend storing these on a stand, which this one will actually come with. That's a little better. So you kind of see the right height of this one is more about right there. And the stand, you know, the colors will match, but essentially that's the stand. And then it just kind of nestles into the bottom there. That keeps it stored in full droop so that you don't sag out the springs unnecessarily. So that is the first, I guess, full assembly from scratch of the new TB RD01 trophy truck kit that competes with the MD RD01 that we have in the store already. This one has a number of improvements. It's also a little more compact, so it kind of takes a slightly different approach. Hangs the weight a little bit farther off the rear, a little bit shorter wheelbase, slightly different A-arm geometry, longer A-arm, and the whole thing is made as a single piece. And so that's pretty good. And so, like I said, we've just been going through. This is a first sort of test assembly, so working out best practices and going through and checking all the parts from the CAD to make sure that we didn't miss anything or that there weren't you know, parts that weren't right. We did find a couple things. We found mostly a few, you know, in the snap dot hole. They've got this chamfer here, and that's necessary because it helps guide the snap dot in, makes it kind of more pleasant to install all of these. And if that chamfer is missing, you can still get it in, but it becomes very difficult to get it started. And so just found a few of these components that we made for this that were missing those chamfers, so we went through and added that all in. We're looking at some colorway options. Let's see, do I have those available? We could jump into a key shot here real quick and kind of look at some of the renders that we've got going on. The consensus seems to be orange, so let's jump to that. So this kind of orange, gray, and black colorway, which I think is pretty cool. Let's move the little comment window over here. Let's give you a couple views of this thing. But we've got some other colorways, so like let's go into the materials, we can change these out. So the other colorway that people seem to like is this sort of gray and green blue, then with a the kind of yellow green suspension bits. And so feel free to jump in and leave a comment with your opinions on the colorways, but there's also the the green, army green and black, and lime yellow green that we just assembled, and then there's also the red, kind of black and yellow green that we've been working with too. But we're definitely going to make a couple of these just to see. I do kind of think that the orange colorway might be a better way to go, but this one it's oddly compelling, even if it's a little more low-key. The colors just kind of seem to work well together. But all that said, the orange and gray and black colorway has kind of McLaren-esque vibes, which I like. So yeah, that's essentially what we got going on for the colorways and the renders. Let's jump back into the CAD. So one of the things we didn't put on here, let's bring our keyboard back here, are the limit straps, but this kit will also come with those, and those just snap through those rear trusses and they loop around just like that through the thing in the tail, and so you can adjust exactly where you want the limit strap to be. And that does a couple things. It lets you control obviously the amount of droop travel, which can keep this thing more composed when it flies through the air if it's not fully drooping out all the way. But it also helps it survive in a crash. And this applies less to it might apply a little bit to like a real trophy truck, but on these, this limit strap is strong enough that if you come down like sideways and really smash that axle and want to jam it sideways, this just kind of helps it limit how far this axle can get pulled like that way. So apparently that became unconstrained. Let's fix that right now. So these should still work. You can kind of see how this front end and these springs and these ball end links work here just by kind of cycling that. But let's see what's happening out here. Let's go check. We've got some something's broken. Let's see. What part is that? Spare ball mates here. So let's just do this. We're gonna hide everything but the parts we care about. pretty sure what's breaking is in here somewhere. So let's go back down. Just work through these. Yep. So I think what happened, so one of the things we found when we did when I just did the assembly was that this axle did not have this little chamfer that I was just talking about for the snap dot. So I went in and added it, but what that did is it probably deleted that original feature of that line, and so we're just going to have to reselect it. And we're probably going to have to do that for these two as well. So that's looking good. Let's see what else is broken in here. Let's show everything again. Not you though. Actually, we can just get rid of you because we've got these. Okay, going back down, we're fixing broken mates. Let's see. Mate connector. Yep. The same. They're probably all related to this. Basically part 27, so where are you? Let's use the isolate feature so we can see that axle. And what about you? Okay, so now we're moving into the grill. So let's double check here. It's a little slow to update, but it works. Can also, I'm probably my limit. Yeah. Now this is a render assembly, one we made for rendering. So these limit straps are essentially modeled kind of in place at ride height. So to make those fit again, we essentially have to drag this axle. So one of the ways we can probably do that is let's go you, you. I'm curious if hiding everything else makes this move. I wonder if we can cycle the axle with the limit strap. That's probably close enough. Silly CAD hacks. Close enough. And it stayed relatively level, so that's nice, which means that one is probably decent as well. Okay, so let's go. We're fixing something. Something's broken. A couple in the grill. Oh, that's because we added chamfers here too. So let's isolate this part. almost certain that one will do. And the other one is probably this one. Okay, so we are now fixed. And everything should cycle. That's about our max bump as far as the hood is concerned, which is pretty good. The internet's been a little weird today. At least the stream seems to be holding up. Okay, so let's see. Let's just recap here real quick. I'll take a quick break and then we'll get back to doing whatever it is we determined we're going to do next year. So we've done a test assembly. We've identified a few components that needed some changes. We made those changes. We worked out a couple colorways. I think the next step is probably doing a print of the orange and the gray and green blue colorways, doing final assemblies of those just so we have the models to look at in the actual colors, and then that gives us a final assembly check as well of the just to make sure I didn't miss anything in this check assembly. And if that's good, we'll get all the parts into the model catalog and all the production files made. We'll get final renders done in the colorway we're going to offer. We'll get it into the store, and then we'll make another assembly video that essentially is the instructional assembly video that the customer would use to put this thing together. And by that point, we should have a really well-developed order of operations for how to assemble it, because you can assemble these things in lots of different ways. Let's see. So I think that's kind of the rough plan for the rest of the day. How much more time do we have? Oh, we got a couple hours, so we're good. We can get all kinds of stuff done. So I'm going to take a quick break, and then I'm going to come back, and we are going to probably rebuild the kit assembly, which is this one here. So this is the one that we actually export to manufacturing. And it has like components like this is a flat component, but in the render assembly, that part has been split up into, see if we can, essentially all these individual components. So essentially this whole thing was designed, folded out flat, and we just used the slice function, sliced it up, added a bunch of mates so that this thing can cycle in a realistic simulation of how the actual parts work, because these are all essentially compliant mechanisms. That's a living hinge, because the TPU is incredibly good at that. It's very durable and very fatigue resistant in this application, at least. And so it's a neat material to kind of design some of these fairly complicated linkages in a small scale factor, and in a way that is incredibly durable and holds up to sort of rigorous play and big jumps and big crashes, in a way that like rigid parts at this scale would have trouble with. And so it's kind of a fun way to do these linkages. The downside is that obviously CAD does not have a great way to model and simulate bendable parts. So we kind of simulate it by chopping it up. We do that with the springs as well. So like a good example of that would be these springs here. Let's hide this part. And so this spring, as it moves up and down, is actually two pieces. And you can kind of see I've made them so that they overlap, so that you don't get a gap, because these are fairly visible. And so this part was modeled, and then I just added this sort of wedge so that as this pivots about this axis, this part always stays overlapping. And that's just a quick trick. If you're going to make like a model that has bendable parts that you want to be able to articulate and model the kinematics of, and you also want something that will render okay. And so yeah, as we saw before, the limit straps do not articulate. Those are just kind of hard modeled in place, I guess. So they're kind of dumb limit straps, and they're really only there to show kind of what it looks like at ride height, since that's all the rendering we'll be doing for now. But if I wanted to go in and like render this out and move the suspension like it was kind of like going over rocks or, you know, landing in different configurations, I would have to go in and remodel these for each one of those cases. There's probably a way to set this up so that it's dynamic and would articulate with it. I don't know if the kinematics engine in this thing in Onshape would like that, but at some point that could be a fun little project, because we will be using this limit strap concept, you know, in a lot of rigs. So maybe one of these days, or that would probably turn into like a week-long project for me, because you never know. I have no idea how to do it, so I would budget at least a week, and maybe we could knock it out quicker than that. But right now it's not worth it. Right now our goal is to get more rigs into the store and build out the ecosystem, as much as I would love to nerd out all day long and just make super smart parametric models. But we do that where we can. I mean, a lot of these, the ClickRigs sort of core connection system is based around a standard kind of set of design components in a grid. So we've got, you know, up here we've got these component generators, so we can kind of generate all the various standard components pretty quickly. And these could be made better, but they're fairly smart parametric models, and then the whole thing is based off this 10 by 10 grid. And then the other day we did build a strut generator. Is that new components? For those for these generating these struts, because essentially this is an interesting way to kind of use this compliant mechanism concept with the TPU and the stiffener to create essentially links in a space frame style construction. And so I intend to use this concept in a lot of places. So the idea, since we're all on a grid, it's nice just to be able to pick kind of the two grid points in space that you want to connect, and then automatically generate a link and a stiffener, as well as the split up components, so that you can have those in a render. Because you know, so like these strut components here, this is the render version, and so this is broken up into 3 pieces so that you can kind of get this bend going on. But if you go into the strut generator itself, you know, it gives you multiple parts. So it gives you the actual one you're going to manufacture, which is just one straight piece, and then it gives you this piece, which is 3 components, and then just some reference geometry there. And so, yeah, point being, that segue, or that sidetrack, was I do think it would be fun to figure out how to make these limit straps parametric, so that as you cycle this axle up and down, they kind of bend as well. So that's probably something I'll jump into. I'd also like, probably sooner rather than later, I do want to kind of do a little bit of research on the best practices for these linkages, because these, I'm going to leave this there because I need this for rendering later and I don't want to realign it, but these rear 4-link systems are, they move a little wonky, and they don't it's hard to get them to simulate smoothly. And so there might be something I can do to essentially allow Onshape's computers to have a better time with that and be able to solve for the motions a little more rapidly. So who knows? We'll see. I might be doing something incredibly dumb in here that's causing that lag. That's all I'm saying. Okay, so let's I'm gonna take a quick break, probably about 5 minutes, and then let the dog out. She's been whining a little bit, and then I think we'll go in and we'll work on this kit assembly, and then we'll make sure that we got all the changes that we made today into this kit assembly, and then we'll send a couple more colorways to the printer, and that might get us through the day today, and then if not, we'll work on something else. So I will be right back. All right, we are back. Let's turn the AI camera on. Okay, so and yeah, I saw the applied. I'm not sure. We got one viewer right now. I'm not sure if that's Stephanie Moore, but it'll be released sometime this week. So hopefully in the next couple of days, but by Friday at the latest. We're kind of on the home stretch now. So this will be in the store at ClickRigs.com by the end of the week. We've got more votes coming in too for the gray and blue-green colorway, which I do think it's pretty classy, as they say, or as Sinway Xavier said, chef's kiss. So we'll see where it ends up. I am partial to some of the garish colors, but I think the gray and blue-green might be winning out here. So. Are we losing our internet here? That's not a good sign, is it? We're back. That's good. This dependence on the cloud is a mixed bag. Okay, so what we are doing now is a little bit of boring stuff, but we are just going to go through and make sure that I bring this over here. So I keep missing comments as people jump in and out, and then I look over and like, oh, that comment was from 20 minutes ago. I'll still respond, but I haven't. If anybody knows how, I'm using Ecamm for the streaming and the switching, and so if anybody knows how to set Ecamm up, or if there's a preference to make it give me an audible alert whenever somebody comments, that would be awesome. I haven't really looked into it yet, so that might be super easy or it might be impossible, but that would be helpful, because as I kind of get into focusing on the design, I completely don't see comments and things. So okay, so we are in the kit assembly, and this has all of our components. What is missing here? I feel like our lights are missing. We've got the light connector there, we've got the two, oh no, we're there. So we've got all the parts. Everything looks updated. Let's just go through here. Cool. Another thing that would be nice is if there was a way to just sort of null out all of these parts in Onshape, just like with a push of a button. But that's okay. And so, just so to catch everybody up, these components here are components that are already in the model catalog. So these components kind of get used in other rigs. And then these components are all of the new components that we've designed for this kit in the last, I guess, 2 weeks, something like that. We were at like 40-ish hours of design work as of the start of yesterday, so we're probably 48 hours in. My guess is if we get this whole thing wrapped up by the end of the week, we're looking at roughly, because I do this for at least 4 hours a day, at least this design stream part and the specific design work. So we'll probably be 60 hours into this kit, and I will say that's one of the things that is sort of important to me and why I started ClickRigs, because I grew up, I loved Lego, I loved building things, but I also love trucks and like suspension and off-road stuff. And Lego is awesome, but it's also not the greatest at making sort of really dynamic vehicles with. I mean, you can do it, but it's a lot of work, and they just weren't designed to be sent off jumps and to kind of have rough play and simulate actual suspension motion. And it wasn't really designed for building vehicles specifically. So I kind of wanted to create essentially a Lego system, a toy construction system of blocks and components that can all be intermixed, but it was specifically designed for kind of building vehicles and machines. And so that's what ClickRigs is. And as you can tell, I grew up, in Southern California. I grew up just immersed in off-road stuff, and it's something that I love. And so you look at a lot of toy trucks kind of on the shelves at Target and in the toy stores, and a lot of them are cool, and some of them are hyper realistic around like semi trucks and garbage trucks and things like that. But then you kind of look underneath, and then the actual functioning components of them as far as suspension and stuff goes are clearly not designed by somebody who is kind of immersed in this world. And so I wanted a toy truck that essentially let you do a couple things. One, I wanted one that was clearly designed for people that were into off-road trucks and kind of knew what they were looking at, or people who wanted their kids to kind of start learning about that. And then I also wanted it to be modular so that you can design your own things, because I think that's an important factor. I think kids and adults honestly should learn that you don't have to accept things as they're given to you. You can take something and you can modify it, or you can take something that has never existed before at all and create it. And so I think sort of one of the building blocks or the gateways to figuring that lesson out, that the world doesn't have to be what it is or what other people are telling you it needs to be, is by building things and making things. And kids obviously, 8-year-old's not going to walk out into the garage. Some of them might, especially this day and age, and start welding and building a real race car. So you got to start somewhere, and the ClickRig system is really designed for that. You can build these kits, these rigs as they are, but then you can take the parts apart and mix and match them and create your own stuff. And then if you want to really get wild, you can start learning CAD, because this same CAD system I'm using is freely available, with some limitations, mostly on model sharing, but to anyone that wants to start learning it. And so you can buy a similar 3D printer to the ones I'm using here. You can jump into CAD and you can start designing your own components and modifications for these rigs. And so that's something I would love to see happen. And so that's a big part of sort of the ClickRigs ethos and why I'm doing this. It's because I wanted toy trucks that were clearly designed by people who love off-road trucks and suspension, and kind of wanted to build toy trucks that realistically simulate that and can be used in very dynamic play, where you can send them off jumps and down ramps filled with obstacles and things like that. And so that's why we're doing this. Anyway, that was a digression, and I'm not even sure how we got on that topic, but that's what's happening here. And so, mostly I was talking about how many hours of design time are in this, and so that to me is just a key part of this system, because this, doesn't take as long, obviously, as designing a real vehicle, but there's a ton of attention to detail in all these little components, and there's an analog and everything here to something that you, like in this kit, that you would actually find on a trophy truck. It's not meant to be an exact replica, because I think those are cool, and there's a ton of neat stuff in sort of the RC world, where these little rigs look like tiny exact copies of these these neat real life vehicles, and I think those are rad. But one of the limitations that has is they're meant to be what they are, and you can't easily take them apart and just make them into something entirely new. And so I think the more you start completely replicating something in real life, the more you're telling somebody, here's this thing, and it is what it is, and it's not meant for you to change. And so, there are some neat people doing neat modifications to all the RC stuff, but again, that requires a larger commitment and a larger skill set. So the idea with ClickRigs is it's a starting point into that world of making your own stuff. And that takes time. A lot of time goes into that. So let's get some, speaking of time, let's get some work done here so that we can actually release this thing by the end of the week. I was hoping to have it all done by last week, but that's how these projects go. And we added a lot of neat stuff, like, like these, all these lights and stuff got massively improved. And yeah, we made a number of improvements, the side pods, the limit straps, this new clip system. So yeah, there are good reasons why it's taking a long time, but we're just going to get more and more in. And after this, when this one's done, we're gonna start in on a we've got a rock buggy, a leaf spring rock buggy, and then we've got the Earl Motors Baja Race Commando, which is a desert race leaf spring Jeep, and but we don't have a linked rock crawling buggy. So that's what we're going to do next, is a rock crawling buggy that has linked suspension front and rear, and so that'll be kind of fun. But for now, let's just double check. What do we have? I don't think we're missing anything in here. All these parts have been updated, so we're gonna export this whole assembly. What I might do is get the gray, blue, green colorway printing, because I'm pretty sure, I know we have some somewhere. It might be out at the shop, not here in the design studio, but I can go get some. We should have some tomorrow, so maybe the goal will be to get kind of an orange and a gray, blue, green colorway made so that we can put those together tomorrow and kind of see where we're at. So you know what? What are we missing? We're missing the snap studs. So let's cancel that. Let's just get them in now. Going to insert, we're going to go to other documents. We're in our model catalog, which is the repository for all the, so all of these things here are the pre-existing parts in the catalog. And again, all of these are interchangeable, so you can kind of mix and match them around. What we're looking at, I think we want 38, yes. That's just going to be a snap stud. And how many of these do we need? Let's just count here. Let's go through these. And it's got 2 there, got 2 there, so that's 4. 5, 6, 7, 8, and then here got 3, 4, 5. So, but I want to add more. So 8, 9, 10, 11, 12, 13, 17, 18. So we want probably 18. So usually with these little components I include some extras, so we're going to do 20 of these. I think, let's go to the browser. I think we can Let's do a pattern, right? It's kind of interesting. What is going on there? It's better. So 5 by 4 should be 20. Plenty. Okay, so you know what? There's one thing I wanted to try. So where these stiffeners snap in, this kind of black stiffener rib where it snaps into the trailing arm, and not just the trailing arm. Let me pull up some. I'm gonna show you here. So we've got, this trailing arm body is made up of a flexible material. It's incredibly durable, by the way. And then these, where it thins right here, that gets pinched, and what that does is it lets you simulate essentially a ball joint or like a Heim joint. Problem is, we're putting a load through here and we're putting a ball end link there, and so what would happen is without this stiffener, this part is just going to bend. And so we also have this rigid component, and it has these little tiny snaps, which are kind of hard to see, and then those made up with these snap holes, and so that kind of basically just snaps and connects those two together, so that now that's a rigid component. One thing I've been noticing is I would probably like this interconnection to be just a little bit tighter, a little bit snappier. And so I think what I want to do is I want to just make these snaps just a little bit oversized in relation to this component. I'll jump in here and I'll kind of show you. Let's see, real quick, let's just update all of that. Cool. I think, let's see, where were those? That was in truck layout. Let's show all these parts here real quick. This is just where we were kind of roughing out a lot of the concepts and then designing some of the initial components. And so essentially all these parts have these stiffeners that snap in that I want to adjust. And so the way I make these in CAD is let's isolate this. Actually, let's isolate this one first. the green part here, the flexible part, is made and it doesn't have the cavities for the snaps in it. And then I model the snaps, and then I use a Boolean, which essentially you can do a subtract. So it's just saying where there's overlap of these two parts, subtract the overlap from one of the parts, in this case the green. So there's a couple ways we can do that. I can either do the Boolean and then go in and oversize the snaps, or what I'm wondering is if let's see. So one of the things we can do in Onshape 2, if you go up here into the feature tree, you can search and filter. So I just want to show all the Boolean features that we have. So now it just simplifies this list, and I can just kind of hover over it, and you can kind of see in the workspace it outlines kind of the parts that feature in the tree is affecting. And so I can just kind of go down. Try to find. So that one is affecting that triangle link and all the snaps. And that one is there. It should have one somewhere for those front. Yeah, there. So let's start with that one. Another thing you can do is you can select the part, and usually it will, but maybe not when we're filtering. Interesting. So if I double click on that, we've got our Boolean feature. We're doing a subtract. The tools that we're using are the stiffener, so that's this part, and then the target thing we're going to remove material from is the arm. So that's the tool, that's the target. You can do this thing called offset, and it gives you, I guess you can do a reverse on that. So let's try that. Let me isolate this component. And so you can either offset all, which we don't want to do because that would also offset this whole face, and it would essentially make a little step in there. We want these two faces, this face and this face, to touch. So we just want to offset essentially this. So we're selecting these three faces. And then you can do an offset distance. And this is where we're just going to have to kind of make a guess, because it's kind of it's a feel thing, so there's no way to really like calculate exactly what that needs to be, and it wouldn't be worth the time anyway, especially with printing, because we can just try some. And so if it's 0, it's basically going to be 1-to-1. It's going to remove exactly the same amount of material in the exact shape of the snap stud. And so what we want to do is we want to remove a little bit less. And so let's see, up printed. I'm going to say let's go to our handy feel caliper test, where we just kind of like, I don't have these are all done in millimeters, and I honestly have just from all the machining that I have done, I have a much better feel for imperial measurements. I kind of like, like 0.02 of an inch will look like that or feel like that to your fingertip or your fingernail. I'm less intuitive. I don't have a good sense of it with metric. It's getting there, and all the ClickRigs kits are designed in metric. Well, one, because it's in theory it's better. And also because all of the additive manufacturing stuff is done in metric, so it's just easier when you're designing a part to like work well with a machine to be dealing in metric units. And I'm just kind of eyeballing and just saying, yeah, I think based on what I know about this material, I feel like something about like, it's like 0.3, it's going to give a 0.6 overall. So I kind of feel like 0.2. Let's just see what that does. And then let's not isolate, let's isolate this one. So I kind of want to see let's call it good for now. I'm just gonna isolate that. Let's jump back into here. I just kind of want to see what the effect has. So, if we go 0, that's where we were, and I was saying 0.2, but we're actually going to want to flip that. So let's say it should get smaller. But that also brings up, so if we go this route, that works, but we're going to want to do something a little bit so the issue, remember we selected the 3 faces. That's going to include this fillet and this face. And if we offset that 0.2, we're also essentially bringing it up. And we don't want to do that because we definitely need the depth. So we just want to understand, like if we've got all these and they're 0.2 too shallow, that whole stiffener is not going to sit flush with this face. And so what we want is to, hey buddy, go lay down. I actually think we just want to do the perimeter. So let's just start over. You can deselect these, but sometimes it's easier just to start from scratch. So I think we should just be able to do these. And what that'll do is it'll essentially just make it tighter, but still give us the full depth. That's the idea. So I'm not sure why. There, okay. I think because I was in this faces to offset, and therefore I had components in the stiffener selected, and so when I went to isolate, it wouldn't do it. So by jumping in, clicking into here, and then clicking on the part I wanted to isolate while I'm editing this feature, seems to do the trick. So what does that do? Just to double check this again, so we go 0, looks like that, looks like that. Let's just check it, and then what we'll do is we'll go in and we'll double check just that we do indeed have the clearance. So what we're worried about, we want to go from this face to this face, so that's 2 millimeters. We need to have a corresponding pocket on the trailing arm that is also 2 millimeters. So we want there to there, and we've got 2 millimeters. And so that is good. think what I should probably do before changing all these, we'll just work with one component. I could just create a quick, to make this fast, we could, let me just do that. I'm just going to make a quick, let's just hide this real quick. We're going to make a quick test, snap fit test part, just so we don't have to print out a whole trailing arm every time. And we can use these components because nothing on the stiffener is going to change. And so let's hide you. I'm just going to, and sometimes when you're prototyping and kind of iterating through stuff, it makes a lot of sense to create just a test component. And let's just call that and let's just extrude that. I don't want to add it, and so that's 2, so let's just say 3. Perfect. And then now what we can do is we can add a Boolean operation. Subtract, this is the tool, this is the target. We're going to do an offset. Isolate this real quick. Faces to offset, it's just going to be that one. 0.2. And just like that. And so now we can just print out this this piece, which should print much faster than that whole trailing arm, and then we can just kind of test fit. If we wanted to, we could do multiples of this, depending on how many you're going to test. I think we're going to be pretty close, but if I like had no idea, or if I really wanted to dial in like something perfect, here the fit just needs to be a little bit tighter. We're not trying to nail like a really slim window. But if we did need to do that, what I would do is create a bunch of these, with each with a variation, and then I would just print all those out at once, and then just go through and like try them all until I found the one that I liked the best. But for now, we are just going to export that. And I'll jump into the slicer. And use the same settings that we would print the trailing arm in. And slice that up. Make sure we got a build plate on there. And so yeah, the printing time for this is 2 minutes and 16 seconds. It's got 10 and a half minutes total time. Usually these A1 minis come in a little bit under that though. All those are off. I guess we could time it. See, I'm curious. I'm going to give it, I'm going to be kind to it and not count the time that it takes to send the file to the printer, because sometimes that's been lagging here a little bit. I'm running them in LAN mode just so it doesn't have to run through the Bamboo servers, but it has been lagging. It could have to do with the way I've got the network set up for these cameras, or all running through a network switch, and I'm not an IT person, so it's possible I've got a really poor configuration. There it is. So we're going to start, and we'll just we'll see how it compares, because we were, let's see, it says 10 minutes 38 seconds total time. We'll see what it comes out at. For now, one of the things we can do, let's jump back into the browser. While we wait, let's create a variable. I'm going to call it stiffener snap tighten, and let's clear this out real quick. So the way Onshape works is you can add variables, and then it's just a feature in the tree. We actually needed to, I like to put all the variables at the top so that all of the, it's a long tree, all of the features can access it, because and we'll just put this in parameters. And the way the feature, if you're not familiar with parametric CAD, the way a feature tree works is it's essentially it's a timeline, so it's time-based. So something that's like, say, here can't reference something that's like, say, here. It can only reference things that came before it. Some people hate that. I happen to love it. It fits really well with, I'm kind of like a story thinker, and so to me this is like it's like the record of the story of the design, and so that kind of linear time-based feature tree just makes a ton of sense to me, and it really helps me stay oriented and helps me understand how this parametric machine kind of works. And so yeah, don't even get me started on philosophical CAD discussions. I could go on all day, and most people are not interested, but I find it fascinating. Some people are very interested though, and if I ever, when I run across that kind of a person at a party, yeah, it's probably to other people it's a cringe fest, but running into those kinds of people at parties makes my night. So let's see. We added a variable, and so what I can do, let's go back to our Boolean, and actually let's show the trailing arm. We can just apply that variable to the value and the offset amount for all of these booleans, or all of the ones that apply, and then that way once we figure out what we want to change it to, we can just change it in that one spot rather than having to go through all of these. So especially if I find that, you know, we do the manufacturing tests tomorrow with the other colorways, it's like, you know what, actually in actual production that needs to be tweaked a little bit, and so it'll be easier to go in and make that change. Let's see. So we got the faces. So what we can do, we can go into this offset distance, and we can do pound, and that'll bring up all of the variables that we have access to, and we can just select that one, and that puts in 0.2, and then now that will be, and then we'll just go through and do that for all of them. But we just got a part off the printer, so let's so that part just finished, 4 minutes 58:42, and probably that 42 is my lag, so you know, we'll call that 5 minutes. And what do we have in the preview here? Total time 10 minutes 38 seconds. So we essentially cut that time in half. That's pretty consistent with what I've been seeing. So anyway, that was just a little aside. I kind of had always noticed that it seems to complete a little bit faster than it says. So 50% is probably a little higher than I would have expected, but let's pull this part off. Okay, so we've got our little test piece. So I'm going to start and just kind of get a feel for what we're doing now, and then we're gonna okay, so that's definitely tighter. So I think that feels good. This is just a single piece when you've got multiple essentially points of contact. So like when we got a whole bunch of them in a single piece, it's going to get even firmer because you're sort of, you know, no manufactured object is like perfectly to size. No, you know, like even the best CNC machine in the world is not capable of making something that's, say, exactly 1 inch or 1 millimeter, like in length, or you know, to make a 1 millimeter cube exactly, like perfectly, as many digits out is impossible. So it's just, you know, different machines can do that, essentially a different number of digits out. You know, that whole field's a lot more complex than that, but just if you didn't know, no manufactured object is perfect, and so that is especially true with additive manufacturing. So there's variance from part to part, and when you've got a whole a whole bunch of points of contact that you're mating up, you're going to notice that essentially the more points that you're touching. And so, you know, with this thing, we've got one test piece, which gets us close, but to really know that we didn't overshoot, because what usually happens is it gets harder because you're kind of having to stretch the material more to make up for all of the variance. And so I think that feels good, though. The question is, when we scale it out to having multiple snap fits, will that be too hard to get in or not? I kind of like to err on the side of stiffer, because once these pieces are on, they don't really need to come off. And what can happen as these, you know, go through rough terrain and have crashes, these sometimes will start to just peel up a little bit, and you have to just kind of, especially this triangle link in here, so you have to kind of go in and smash them back down. So I think making those tighter, and this is a system standard connection, and so dialing this in is always worth the effort, because we use this in a lot of places. So this is our opportunity to improve that part. So let's go to the browser. Let's just get, I'm going to go, while we're adding the variable, we'll print Let's isolate these two. I just want to double check that we've got, that's 2.599 versus 3. So let's just export this, and we'll get this printing, and then we'll go in and we'll add that variable into the offset distance for all of these booleans. We're on time. Oh yeah, we've got another hour and 15 minutes. We're gonna get all this done. Should we do another time just to see if it's scales with total time? Because what I'm wondering is if the preparation time, let's go into the slicer, accounts for that 5 minutes difference, and therefore we're always going to get a 5-minute change, or if it kind of scales as a percentage. I don't know. 2 data points won't totally tell us that, but I am curious. If it's exactly 5 minutes again on a 25-minute total time print, then we can probably assume that most of that is a misjudgment in the preparation time, or preparation estimate. So let's just get that sent. Carbonated water. If anybody knows any ways to speed up the sending a sliced file via LAN mode to a Bamboo printer, any way to speed that up, just when you're seeing this video at some point in the future, just leave a comment and I will look into it, because there we go. We'll start our timer here, and we'll see what we end up with. All right, let's jump back into the CAD. And let's go in and add our offset. And we're just doing these faces. And our offset's going to be that variable. I'm going to flip it. Well, let's just double check it. $2.599. And let's just go to the top and just get an eyeball. Nothing stands out, so we probably got them all. Let's hide these because these are not the right part. The arm flat, I think, is what we want. Yep. And that's interesting. Let me just double check here what we got. Okay. Looks like we got them all. $2.599. Excellent. Okay, so I'm pretty sure that's show all the parts here. We're gonna have to do that in the stiffeners too, probably. So while we're waiting, let's jump over into our strut generator. I don't think we can reference, that would be rad if we could though, but I don't think we can reference the variable. We could try. No. Yeah, I don't think we can reference the variable from before, from the other Part Studio. Let's see. There's only one in here, so and double check. 2.599. So that is correct. I guess in theory too. this should probably be filleted. Let's just double check that. .6. We'll double check. In some ways we might be able to just get rid of that fillet and have that help lock it in even more. In fact, let me so this one is the same snap size. That's my concern. With the smaller hole and the no fillet, it becomes much harder to get on. So I think we add a fillet there. So let's roll back to here. We're just going to fillet that 0.6. Roll to the end. That's better. Let's just rename that since this is a generator, so we want to keep it a nice, clean, understandable model. So we'll label that just so you know you can go through this tree and kind of have a sense at least of what everything is. Let me double check too, because 3 degrees. Just want to make sure we're being consistent here. .3 Okay. The standard snap has a 4-degree draft, but these little tiny ones aren't standard snaps. They're just really just to permanently attach a stiffener. And so once those two components are together, you'd never interchange them. So like this is an assembly that stays together, and this total assembly is a modular component that can be used in other rigs, but the individual pieces of that assembly are not. So this you know kind of gets treated as a monolithic element. Let's see, we're at 11:24, 67% done. Yeah, see what it comes out at. Curious. I'm trying to think if there's anything else that we wanted to change. That was actually one thing I just noticed. Let's see. Where did the stand go? Here's the stand. So this little center skid plate is a cap, and it's those aren't actual snap connections. They're just kind of locating holes, but they're meant to fit loosely over a standard snap. These do not. Because what I want is you to be able to just sort of set this on the stand, and then it generally stays there and doesn't slide around, but you can pick it up off the stand without the stand coming with it. So I'm kind of curious what these 4.2. We could make that a little bigger while we're at it. So let's maybe jump into wherever this thing's at. And this is a component that I'll probably start using frequently on all of the rigs that sort of, where the suspension would prefer to be stored on a stand. We'll just make this is sort of the receptacle for that. So 4.6, let's see, so where? So if we made that 5. And I almost want this chamfer to be like really big. Does that give us enough? My guess is that would not print well though. But if we got rid of that one, actually let's undo that. Let's just make this small. Sweet. And so a little more clearance there, and then just kind of a bigger guiding, so it's easier to set it onto the stand when you can't see. Kind of curious what where we're at on the slicer. So again, it was predicting 25 minutes. We are at 16 now, 17. It's saying like 2 minutes left. So we might be coming in close to the 20. That 5-minute difference might entirely be prep time. Anyway, let's jump back into the CAD. just wrapping up all little details. So we made this component bigger, and this is a receptacle for the stand so that you can store this thing with the suspension in full droop so that the springs don't take a set, and also just because it looks cool on the stand. We are printing out currently a new trailing arm with slightly tighter snap holes for this trailing arm stiffener for actually all of the pieces that use this flexible part, stiff part concept. And if that looks good, we will go to our kit assembly here, which has all of the components, and do another scan through just to make sure we're not missing anything. Then we'll save these out and start building the various plates. So basically almost all of the ClickRigs components are built around 2 colors of a rigid material and 1 color of a an elastic material. So, and when those are made in a cell of printers that basically 3 of them. And so we kind of build, we call each one of those a plate. So we've got like a plate for these components, and then a plate for these components. Although I did kind of move, show you. So this was the one we just assembled, so I kind of brought those 2 middle pieces into the main body color. So let's go kind of group these up. So these are all of our main body components: red, green, orange, whatever we're gonna end up going with. And so I also want this component to be part of that. And these 2. And this one. Cool. So this is 1 color, this will be 1 color. These will actually be in this group. Alright, so it looks like we got our print part done. I didn't stop it, but I'll say roughly 20 seconds or 20 minutes. So yeah, about 5 minutes. So my guess is that discrepancy, why it always seems to be faster, is it's like analyzing its prep time by 5 minutes. Not super important, but so that's our new one. And same stiffener. So basically we're comparing this one versus this one, and we just made these holes a little bit smaller so that this connection is a little tighter. And it worked well with our test piece, but now that we've got so you have to work a little harder and kind of peel them on, but that's a much better connection. So I think we're just going to run with that. I think that's a good, compared to like this one where it almost like falls kind of into place. And if you do that, it pops up easier. Whereas here you really have to push them on. It's a lot more resistant. Excellent. So back into the kit assembly, and just to check, this should be updated now, and so these holes should be 2.599. Yep. Same with these. We're just making sure that we got the updated parts. And same with these. Yep. Do I have these grouped up correctly? To the TPU. Oh, you know what we need in here? We need the limit straps. So that's a pre-existing model catalog part. And there are two of those. And those are the rear axle limit straps. I'm going to show you. So it's these components here. And they just, you go up to the rear axle truss and then loop around there, like through a belt loop or through a belt buckle, and then you can adjust how much limit you want. Again, lots of detail in these kits, so if you've got a kid or an adult in your life that loves off-road truck stuff, this kit will not disappoint. So let's see, we got everything in here? I think so. Select it all. I'm going to export it. And then what's going to happen is we'll make a couple of these kits in the proposed colorways. We'll do a final test fit, and then if all that looks good, then all these new components that we made will essentially get assigned ClickRigs part numbers, and then they'll go into the model catalog, and then we'll rebuild these assemblies using all part numbered components. Okay, so here's our all our stuff. Comes in as one big object into the slicer. So we're just going to split to objects. And then what we can do, let's just do auto. If we select them all, does that apply the auto? And this is going to be all wrong, but yeah. So let's see. I'm gonna pull all the TPU parts down here. Probably all of them. We'll assign and then let's do the main body color parts up here. Start there. Oh, weird. It's almost kind of like that. Okay, so now I just want to make sure that I've got all the right colors where I want them. Two of those, we're going to do one of the main body color. Pretty sure that looks good. Hold on one second. we are back. Now, let's jump into the slicer here. So we're just slicing up the kit. We're obviously missing some parts here. Sometimes the auto layout let's see if we can get it to put them on. Doesn't want to do it. Let's see. Oh, we got a couple parts we need to move over anyway. This part for sure. What else did I miss? Oh, that's right. We're doing these two as main body ones as well. I was wondering why it fit last time. I know you guys can do it. Do not intermix my parts, please. You bastard. Okay, that's better. I don't like having parts too close to the edge because generally that's where the plates get touched and you get a little finger oil on there. And then I know it wants to do that, but we are not gonna. We got a couple things we need to adjust here. Let's just go in and double check everything. Okay, I think that's probably good. And then let's go in here and do a couple things here. So essentially this part, all the springs get printed with 100% infill. I think that's it for all the settings. So we will print out one of those. We'll do a test assembly tomorrow, and if that looks good, what we will do is get all of these new components into the model catalog, and we'll rebuild the render assembly and the kit assembly with those model catalog parts. That way, when we come back in here at a later date to reference anything in here, instead of like some random part 1 or 70mm trailing arm, it'll actually go to a part number in our catalog, which those parts are stored here as well as in step files that can be directly accessed in production. So these are all the model catalog parts. You can see they all have a CR for ClickRigs part number, and those basically are locked in. And so when we design a new kit, we can pull, if there's a part that already does what we want to do, we just pull it from the model catalog, so we don't have to redesign it and pull it into the assembly. But for all the new parts, we basically model them, just in this new document, and just kind of name them whatever we want. Once we get all the parts, like part 3, that doesn't mean anything. We'll export this part, bring it into the model catalog, and then bring it into an Airtable database where we will assign it a unique part number and get all the new parts in, and then rebuild this. Basically create a whole new document. In fact, I could probably, let's show you. The render assembly might be broken, but so this new document is much simpler. You can see there's not much going on. It's just essentially there's a bag assembly, a render assembly, just a little render studio sometimes, and an exploded one for doing instructions and stuff. And so this is our render assembly that we would output to do the renders for the final product stuff. But if you look at the all the components that are in it are ClickRigs part numbers. And then if you go into the bag assembly, it's sort of broken out by the plates. So you can see, like, here are all the parts that print in black. Here are all the parts that print in white, orange, gray, and then TPU components. So it just keeps everything simplified. And then later, if I say, oh, you know what hood was that we used for the Baja Commando? I want to use that in a thing. I can go to this assembly, and then I can select the part, and I can see that, oh, it's the CR118. And then if I wanted to I think I can switch to it from here. Open link document. And so I can open it, and I'll go into the model catalog, and then there's just that component. It's got a part number, and then also for rendering, it's been split into different faces have different object or bodies, so that when we render it, we can apply different textures to it. So it's pretty cool. Let's see. I wonder how much time do we have left? About half an hour. Starting to get into some of the extra boring stuff, but let's jump back into Keyshot, I believe, and just kind of take a look at the so far we've got more votes for this colorway. Oh, not that one. For this colorway. So I think that's what we'll print out as our next test assembly. Kind of take a look at the different views here. And kind of change up the lighting depending on what you're trying to highlight. Let's see. So I'd be curious to you to shoot some slow motion video once we have kind of learned the colorway that we want. We'll shoot some slow motion obstacle video to kind of, I'm really curious to see how it compares to the Mayday rig. You know, they're very similar in that they both A-arm front, triangulated 4-link rear. They're kind of designed to compete against each other, but they take slightly different approaches. You know, this one, the overall length is the same, but the trailing arms are a little shorter, so the wheelbase is a little bit shorter, so that this weight of the spare tire hangs a little bit farther behind the rear axle. It also means the whole thing can be built a little bit lower because this axle can tuck up in front of the spare tire instead of right on top of it. If we go to kind of the website, you can see, so it's the MDRD01 desert truck that this one competes with. And so you can kind of see, these are a lot longer, and they kind of splay out. It's a much simpler design, not quite as much detail. So it's a little more, it's a little wilder, I guess, is how I would describe it. It's probably a little more wheel travel. It's a little bit heavier. I think it's like 25 grams, 30 grams, maybe heavier than the new one we've been working on. And so it's a little more delicate, but also a little bit crazier, a little bit more wheel travel. But generally very similar. I mean, essentially the conceit that we kind of designed around was this fictional rivalry between a racer named Mayday, who is super innovative but doesn't have a lot of money, so she builds these kind of like simple but wild rigs that kind of have a lot of innovative features. So for a time, this was the most advanced rig in the ClickRigs store. And then her rival, Thorne Buckingham, what he does is he basically like steals all of her good ideas, but because he's rich, he builds them in a much more refined way and kind of makes improvements on them. And then they just keep leapfrogging each other in this sort of rivalry. So, in a few months' time, or 6 months or next year or whenever, we'll release a new Mayday rig, which will be the MDRD02, which will be filled with all kinds of interesting innovations. Don't know what they are yet, but we'll try to ramp it up. And then, 6 months later, we'll come out with the Thorne Buckingham version of that. So they're always trying to outdo each other, but they have slightly different styles. But you can kind of take a look at how the Mayday one performs in slow motion going down the ramp. So pretty good. I think we've got some more. Let's see what do we have in here. Kind of multiple attempts.
You fail. You fail.
Gets unsettled right there. Corrects. Oh, can't quite hold on to it. These are super fun to watch in slow motion.
I bought all my yacht rock at the yard sale.
And so a lot of the way you control it is by like how far up the ramp do you let it go, how much speed does it have when it hits the first set of obstacles, whether or not you're running a single or like a double tire stack. Ooh, that one was close. That was good. Oh, it stayed settled. It's not the one, by the way. Just bucked on that last jump. We are gonna get it though. It's coming. Oh, just kissed that little mound there. And nope. Ooh, skimmed that one. Oh. So it made it, but we skipped that last obstacle. So here we go. I think this is the one where we get it. Okay, came in heavy and we boom. Nice. Anyway, kind of fun. So I'm curious to see how this one does. So we'll throw a little ramp up here and we'll throw some of the new terrain on it too. terranium system, which we're gonna get one more 4-link rock crawling rig into the system after this, and then we'll work on getting terranium released. And terranium is I think we've got a couple in the store, but I haven't really done anything about it. So I'll kind of show you a couple things here. So we've got this rock buggy, which is pretty cool, and it's a leaf spring buggy, so solid axle leaf spring, and it's not really meant to hold up to like big jumps and stuff. It's meant for slowly articulating over kind of fairly extreme terrain. But what I really want to do is kind of a higher performance version of this with a 4-link setup. So solid axles, but linked front and rear. And then I might actually use the single seat cab that we just designed for this new trophy truck we're working on now. And I might use that cab kind of in this design, which is sort of kind of what I've been roughing out with like this sort of concept. So this is the same cab, and then this is the hood off the K13 rock buggy, and the bed, and then a couple of little jerry cans, and then I'm just using the strut here as like a cab brace. So kind of something in that vein, but a little bit longer, and then 4-link axles. So we'll get that in the kit, and then we'll work on terranium, which is probably in here, maybe. Just might not be listed. Nope, it's not in there yet. Oh, there it is. So yeah, I don't have I just have the booster ramp in there, but we can kind of go over this real quick too. So this is the terranium system that we're working on, and these are basically a set of terrain tiles that they're square, and they're all the same kind of square pattern, and then you connect them together with these little flexible clover connectors. And then there's a set of rings so that you can stack them, so you can build them out into a grid and connect them kind of together like this. But over here you can kind of see there are these rings, and you can just stack the rings as high as you want and then put these tiles on top, so you can kind of build in 3 dimensions, which is pretty cool. And then just here's a short little video jumping a flying pancake over them.
Well, bad news is this. We've sold out of the FP01 Flying Pancake.
What's the good news?
There isn't any. Seriously? No, not seriously. Of course we're making more, but that's not the good news. What's the good news?
It almost
Well,
makes it,
we've made
but
a
it
terrain
hits
building
the
system.
hits the little storage
We call
bins.
it Terranium, because that's a mix of the words terrarium, cranium, and terrain.
I don't get it.
But those are the tiles, and you kind of
don't
get a
have-
sense of
you're
the
gonna
scale
wanna buy it.
too.
And an FP0.
In fact, this vehicle is the scale. So, so I think we'll get this new trophy truck into the store. We'll get a linked version of this rig right here, and then we'll jump into terrain, and we'll kind of add some more tiles and just build that whole thing out and do some content around that. And then we'll jump back in and do more rigs. And there's the Baja Race Commando, which is in there now. These should be shipping, so we're shipping these now, or very soon if you have an order for one and it hasn't shipped yet. Not all of them come with boxes, but where we do a collaboration, so this is a collaboration with Alex Earl of Earl Motors. He's an automotive industrial designer, and he owns this, there's probably a picture of it in here somewhere. It's a Jeep 67, I believe, Jeep Commando, that he's made into a off-road race vehicle for racing the Nora Mexican 1000. And so we collaborated with him and did a ClickRigs kit version of his race car. And so this one has this nice packaging that we designed. They all come in these boxes, but some of them just have a sticker. And we don't do packaging for all of them, or the sleeve for all of them, just for the special editions. But we will be working on some collaborations with some other folks here in the very near future, so keep an eye out for those. And this one also comes with a decal kit, which this is the only one that does that. Again, it's kind of a special edition kind of a thing that's got, you know, his race number and his Earl Motors and kind of the, you know, designed after the racing graphics that are on the actual race vehicle, which there might be. I think this is a little video. Part of this shows, yeah, so that's his actual race car right there, and then that's the ClickRigs kit. I think this will loop and end with the car again. Yep, so that was a fun project, and looking forward to doing more things like this. But back to getting this one in. So we are very nearly there. Tomorrow we will, how are we doing on time? I can't get this printing. I need to go pick up the correct filament from the factory. But I will do that. We'll get it printing. We'll do another test assembly just like we did for this one this morning. And if everything looks good, I'll do all the onboarding of the parts not on the stream, because that's not the most interesting thing in the world. But what we might do later in the week is maybe start on the next rig. Well, behind the scenes, I just get this in, and then kind of got a couple colorways, neither of which I think are going to end up being the one, but I think we're almost there. You can kind of see, I don't know if I can move this camera down. That could be kind of interesting. Let's try it. Let's just switch to that one, see what happens. Oh, too far. Just kind of curious if we can get like a side view of these. Return all the lights on. And so you can just kind of get a sense of, like, let's use this as an obstacle. Just how realistically these things articulate. So, yeah. It's probably a little easier to see. We have more light. This camera set up, but just going through, we're going to do one last check. Pretty happy with all of the final changes in here. The wheel retention will be nice. Kind of show you what we got going on there. So in the front, basically front and rear, we've kind of added this little retention lip. So you have to press a little harder and kind of work it on, but once that bearing's on, it shouldn't come off while you're playing with it. So unless you directly pull it off to remove it, that should be much better retained. So it's relying on more than just friction, because the other rigs rely on friction, which for the most part is pretty good, but you know, in a big crash you can lose a wheel. And then same for the back here, similar retention lip. And then on the old axles we used, the axles look the same, but then they had a little slot on the bottom for a wedge. In fact, you can probably see that here. I wonder if it's in the exploded assembly. Oh, essentially there's this little wedge spot right here, and then there's a little elastic wedge that you kind of jam in there and then slide the bearing over, and that kind of provides friction, because this, unlike the front, this axle is rigid. And that worked, but eventually you do lose a wheel, and you can kind of see where the wedge would go right in there. Curious if we have it here. So yeah, you can kind of see that's the little wedge, and the little wedge just kind of goes right in there, right in that nook, and then the bearing slides on, and that's what keeps it retained. But in this one, we now have this two components. So this is TPU, this is elastic, and this essentially slides over this hex of the axle now, and then there's a little retention ring in there, and that gets retained, and then you've got much better bearing retention that way. And then this is a lot easier to deal with, and so shouldn't be losing bearings off of the axles or the front end anytime soon with this new setup, or hunting down a little wedge. But the wedge is going to be fun too. This is all part of to me, this is part of the interesting bit about the ClickRigs system, is you've got kind of these iterations. And so throughout the collection, again, all the parts will fit together, but you've got kind of, just like with real vehicles, you've got these improvements that are made over time. And so kind of at some point in the future, I would love, it's like, oh, that's a classic, like, you know, just like a real classic car. It doesn't perform quite as well, but it's kind of cool because it's sort of all of the original components. So yeah, that's probably getting close to the end of the time today. Tomorrow we'll assemble another one in one of the proposed colorways, and if that looks good, I will probably switch during the stream, and we'll just start working on the next rig, and then behind the scenes I'll get this into the manufacturing system and onto the website, and we'll send out an email letting everyone know when that's ready. So if you're not on the email list and you're watching this video, go ahead and go to clickrigs.com and join it. We don't send out a ton. Mostly we just let you know when we're having a promotion, or when we're releasing a new rig. So if you just go to clickrigs.com and at the bottom and just enter your email right there, we'll send you an email and let you know every time we release a new one. And we're planning on releasing a lot, so you know, we're just gonna keep churning out new rigs as fast as possible. The goal is to grow this ecosystem as quickly as we can and make it as big as we can, because the more more parts that you have to play with, the more creations you can build. And so, anyway, that's all for today. Thanks for watching, and talk to you tomorrow.